data. That's what NASA wants to collect, and lots of it. However, given the limitations of their current technology, they can't just wirelessly transmit this large quantity of data back to the ground like they have been. Instead, they will have to store it on a hard drive. That's where we, SDSU's Team Jackdrop, who is participating in NASA's Floating Dragon competition, comes in. We're working on a system that would not only allow NASA to collect these large quantities of data, but also help them, both safely and reliably, retrieve this hard drive on the ground. This mission requires that we design a system to ride NASA's balloon up to 120,000 feet, which is about 23 miles, in the air. Then, when released by our command, it will detach itself from the balloon and autonomously navigate to a previously determined target point. Not only that, but the system also has to make it to this target point in less than 90 minutes, with the hard drive still intact. To accomplish this, we'll be using a single-stage descent design, where a parafoil will be used like a drag chute. Then, once it reaches about 60,000 feet, which is twice the cruising altitude of a commercial jet, it will change into a parasail that is steered by the control system that we built and programmed. By comparing the direction the system needs to go to in order to get to the target zone to the direction the system is heading, we can figure out what direction the system needs to steer. Since the system will be exposed to such harsh conditions as the cold, we wanted to make sure that the system could function in those conditions. So we put the servos and nichrome wire cut-down mechanism in a container with dry ice for about 6 hours. This allowed us to test them in sub-zero conditions, in which they performed as expected. In addition to mechanical testing, we have done software testing that includes driving around a pre-coded location and plotting our route. Recently, we have received permission to do test drops off the top of the Campanile and look forward to doing that in early May. In February, we were selected as finalists in the Floating Dragon competition among schools like Princeton, Purdue, UT Austin, UC Davis, and Notre Dame. Currently, we're in the middle of refining our control software to submit to NASA at the end of May, after which we'll be working towards our mission readiness review and the test flight in August that will take place at Fort Sumner, New Mexico. Should the system perform as expected, we are hoping to have our technology integrated into many future NASA missions.